chlorination reaction. Okay, now the thing is why the difference for activation energy greater for bromination and the chlorination. So we will see now the energy profile of these two reactions, chlorination and bromination. Okay, so we will see now energy profile diagram for the bromination and chlorination. So a K difference is that in chlorination the K proportion step is exothermic. Okay, so K proportion step in chlorination is exothermic, and in bromination the K proportion step is endothermic. Okay, we'll see on the next slide how they are exothermic and how they are endothermic. So this is because the chlorination forms a strong HCl bond. See, so chlorination generation of after generation of free radical, secondary free radical as well as primary free radical, whatever HCl bond is generating, that one is stronger, having 103 kilocalorie per mole. And after formation of secondary radical for in bromination reaction, so formation of HBr bond is much weaker. The energy needed to this thing, it's 87 kilocalorie per mole. So this is the second factor we can calculate or we can consider for the why the selective bromination occurs, not selective chlorination. Okay, so in this way we will go for the next slide for the reaction coordinate. That means energy level diagram, whatever. So reaction coordinate for bromination and reaction coordinate for the chlorination. If you will see carefully at the energy profile diagram, so you can see for the chlorination uh, starting metal reactant resides over here, and you can see suddenly the transition state is suddenly that one is following the reactant. Okay, so that means transition state energy of the transition state is very closer to the reactant. Okay, so for chlorination the energy profile diagram is like that, and product you will see is rising far away from the transition state. Okay, and it's a sudden drop in energy from the transition state to form the product. So this is the chlorination reaction, energy profile diagram for the chlorination reaction. And here if you see energy profile diagram for the bromination of reaction, if you will see reactant lies on the left hand side and the transition state lies on the side of the product. Okay, so that one lies on the side of the product. So it the energy of the transition state and energy of the product, the difference in energies is very less in case of the bromination. So what is the, by looking closely at the transition state is for each reaction. In chlorination the reaction is exothermic, as we have seen in our previous slide. The chlorination in chlorination reaction the reaction is exothermic, and transition state resembles the reactants. Okay, transition state resembles the reactant. That means the energy level of the transition state is resembling the energy level of the reactant. Okay, so according to Hammond's postulate we could say that this transition state is early transition state. So in case of chlorination, here you can see reactant lying just next to this transition state lying just next to the reactant. That means transition state forms in early stage of the reaction, so we can say that one is the early transition state. And in case of bromination we can say transition state lies next, that means neighbor, very close to the product, so we can say that transition state resembling the product. Okay, energy level of this transition state resembling the product, so we can say that transition state is the late transition state. Okay, so in this way we can say that early transition state is forming in chlorination, and a late transition state is nothing but the product like transition state. Here I have written, so in case of bromination the transition state is product like transition state, and in chlorination transition state is reactant like transition state. Okay, so what what will be the effect of this transition state in case of chlorination and bromination? Okay, so we will see why early transition state is making unselective chlorination, and why late transition state formation in bromination, it makes more selectivity in bromination reaction. Okay, so now we'll go one by one, separately at the both transitions, both energy profile diagrams. So the transition state for chlorination resembles the reactant. Okay. In case of chlorination, we have taken now both primary free radical as well as secondary free radical formation, and we have shown the our reaction coordinate. Okay. So we have to study in detail. So if you will see, for primary free radical formation, energy needed is little bit more, and secondary free radical energy needed is little bit less, and we have seen the difference in between these two reaction. Energy was 1 kilocalorie per mole. Okay, as we have seen initially. So energy difference in activation energy difference is 1 kilocalorie per mole. Difference in activation energy is 1 kilocalorie per mole, as we have discussed earlier. So here now the transition state, both of these transition state for generation of primary free radical as well as secondary free radical, both lies near to the reactant. So early transition state is reactant like. That means energy is same, and it means that energy is same or reactant like means that product, that transition state, that it can very easily again convert to the starting material. Okay, again convert to the reactant. What this means is that for chlorination, difference in activation between free radical pathway at secondary and primary most closely resembles the reactant, which are identical in energy. So there will be very small difference in activation energy between the two. That means this is the thing. And what will be the transition state for bromination resembling the late transition state? Here, if you will see, again reported both primary free radical as well as secondary free radical, and if you see, any presence between these two is kilocalorie per mole. So that one is more different than the chlorination reaction, and transition state lies uh, next to the product. So that's why, and energy difference is low in between transition state and product. So transition state, once transition state you got it, suddenly it can transform into the product, because this is it resembling to the product. That's why it can suddenly transform to the product, which is really the same thing, which is really contrary to the in case of chlorination, because in case of chlorination the transition state is resembling the reactant. So energy difference is low in between transition state and reactant, so transition state suddenly it can convert again to the reactant. Okay, so with the help of energy level diagram we can say that this conclusion. And due to that, as this difference is higher, but these transition state in case of bromination residing or it's resembling the product, that's why the selectivity in case of bromination, free radical bromination, is more. Okay, so this is our conclusion about our chlorination versus bromination. So the total or overall